Hello, my awesome pre-algebra students. Let's talk about Chapter 3, Lesson 4, Solving Inequalities Using Addition or Subtraction. So there's really important vocabulary here. An inequality is any time that something is not equal. So, for example, we could have is greater than or is less than. We could also have is greater than or equal to. We could also have is less than or equal to. Now, in algebra, there's a difference between the types of dots that we graph. Sometimes we use open dots, which would happen when it's one of these two symbols, is greater than or is less than. And other times it's going to be a closed filled in dot for is greater than or equal to, is less than or equal to. And remember, with an inequality, there are an infinite number of solutions. So you can't list them all, and that's why we have to graph them. Now let me talk about some basic examples. Take a look in the margin. Will you please take a second and write x is greater than -2? Well, if you start thinking about numbers that are greater than -2, you could say, well, -1 is greater than -2, 0 is greater than, 18 is greater than. And so what I want you to notice though, could we ever do this? Put in a -2 here and say -2 is greater than -2. And you should say no, you could never do that. And that's why we make this open dot around the -2. I tell my students to think of it like a force field. You're putting this giant invisible force field around -2. It could get really close to -2, but it can never touch -2. And so then we shade everything else that is larger than -2, and you have to put this arrow at the end to show that it will continue on and on forever. Okay, take a look at this example. What if I asked you to graph y is less than or equal to -1? And now in this case I would say, could we put in a -1 here to make this true? And you would say yes, because -1 is equal to -1. And anytime you would say yes, it's true, or you see this little part of an equal sign, that's when it's going to be a closed in solid dot on -1, because it could touch -1. It could be equal to -1. And then we shade everything smaller, everything to the left, and put that arrow. Okay, so let's take a look at example 2, solving an inequality using subtraction. They want us to solve m plus 9 is less than or equal to 12. Graph and check your solution. Okay, so first thing we do is write it out. M plus 9 is less than or equal to 12. And then just like we were doing with equations, I want you to use your red, circle the variable, and bring your wall down. And take a look at what's touching the circle, adding 9. Well, we know how to destroy adding 9. We would subtract 9 on both sides of the wall. And so then let's just bring the m straight down. A positive 9 plus a -9 destroy each other, so they disappear. Bring the symbol straight down, and then 12 minus 9 is 3. So we would get m is less than or equal to 3. And so box that answer. Now you'll notice I did not use their number line because I want you to practice that we would draw our own number line. So draw a number line. I want you to put, we always put 5 tick marks and make them look equally spaced. I always want 0 in the middle. And then I just look at the number I'm trying to graph. See that positive 3? Well, then I'm just going to count by 3s. So to the right of 0, I would put positive 3, positive 6. And to the left of 0, I'd put -3 and -6. And now I take a look at my symbol here. That tells me what type of dot. See that little part of an equal sign? Since m could be equal to 3, I'm going to put a solid closed dot at 3, and then it's telling me shade everything pointing to the left, everything less than. So I shade everything to the left, and I put my arrow. Okay, let's talk about example 3, solving an inequality using addition. They want us to solve -7 is less than x minus 11 and graph our solution. Okay, so take a look down here. I copied the problem exactly like they gave it to me. -7 is less than x minus 11. Then I grabbed my red, I added a line and changed the sign in front of the 11. I circle my variable with my red, and I bring that wall straight down. Take a look at what's touching your circle, adding -11. Well, you know what we need to do to destroy that -11. We need to add +11 on both sides of the inequality. And so now I just simplified. Negative 7 plus 11 gives me 4. I copy that symbol straight down, really, really important. I bring my x straight down, and of course negative 11 plus positive 11 destroy each other, so they disappear. Now here's the deal. This is true, that 4 is less than x. Very true. However, in algebra, we would tell you don't graph it unless the variable is written first. See how the variable comes last if I read it like a sentence? So I want you to practice writing it with the variable first. So I'm going to put an or here, and now I'm going to read it backwards. X is greater than 4. So that's what I wrote here. X is greater than 4. And now I graph it. And let me show you why. Okay, so I know I want to graph the 4, so I draw my number line and I make 5 tick marks. Since 4 is my important number, I'm going to count by 4, so I put 0 in the middle, then I counted by positive 4, positive 8. To the left of 0 was negative 4, negative 8. And I take a look at my symbol. Since x is greater than 4 and it can never equal 4, I'm going to put an open dot, that force field around the 4. And then take a look here. See how my x is written first? Well, when that happens, see this symbol is greater than? It's pointing like an arrowhead which way to shade. It's telling you, shade to the right, shade to the right. So I'm going to shade everything to the right and put my arrow. If the variable is written first, this blue arrow will match the inequality symbol, okay? And that really helps you check your work. Okay, so let's talk about these. Number 1, plus 7 is less than 13. So I copy the problem exactly like they gave it to me. I grab my red, I circle the variable, I bring that wall down. I look at what's touching my circle, adding 7. Well, the only way to destroy adding 7 is to subtract 7 on both sides of the inequality. And then I just bring down my variable, the m. Positive 7 plus negative 7 destroy each other, so they disappear. Copy the symbol exactly like it was written, and then 13 minus 7, of course, is 6. So I box my inequality. M is less than 6. And so I did this time just use their number line because they gave me enough space. So M is less than 6. It can never equal 6. So I put that open dot, that force field around the 6, and then look at how my symbol is pointing. It's pointing to the left. So it's telling me shade to the left. Shade to the left. So I shade to the left and put my blue arrow. And notice how my blue arrow matches the inequality symbol as long as the variable is the first thing I read. Okay, take a look at number 2. A plus 4 is greater than or equal to 5. So I copy it exactly like they gave it to me. I grab my red, I circle the variable, I bring down the wall. Take a look at what's touching your circle, adding 4. So I subtract 4 on both sides of my wall. I bring down the a positive 4 plus negative 4 destroy each other, so I let them disappear. Copy the symbol exactly like they gave it to you, and then 5 minus 4 gives me 1. So I have a is greater than or equal to 1. So now, I take a look at my symbol here. See that little part of the equal sign? A could equal 1. That means it could touch 1. So put that solid closed dot right at 1, and then look at how this is pointing. It's telling you to shade to the right, shade to the right. So shade everything to the right and draw that blue arrow. And if the variable is written first, remember, this arrow should match this arrow. Okay, take a look at number 3. X minus 2 is less than or equal to 3. So copy the problem exactly like they gave it to you, and then grab your red, circle the variable, bring down the wall, and see the minus sign in front of the 2, add a line and change the sign. So take a look at what's touching your circle, adding negative 2. Well, you know how to destroy it. You're going to add a positive 2 on both sides of the wall. And so bring down your variable, the x. A negative 2 plus a positive 2 destroy each other, so let them disappear. Bring down the symbol exactly like it's written, and then 3 plus 2 gives us 5. So now we box our answer. X is less than or equal to 5. So remember, look at the symbol. See that little part of the equal sign? X could equal 5. So put that solid closed dot on 5. It could touch it. It could be equal. And then notice how it's pointing. It's pointing to the left. Shade to the left. So we're going to shade everything to the left. and put our blue arrow. And remember, when the variable is written first, this inequality symbol will match the blue arrow. Take a look at number 4. They gave us -6 is less than z minus 7. So I copied exactly what they gave me. Grab your red, circle the variable, bring the wall down. And with the -7, with your red, you want to add a line and change the sign. So now, look at what's touching the circle, adding -7. Well, you know how to destroy adding a -7. You're going to add a +7 on both sides of the wall. And so now, a -6 plus a +7 gives me 1. I bring the symbol down exactly like they gave it to me. I bring the z down, and then -7 plus +7 destroy each other. That's a 0, they disappear. Now remember, this is true that 1 is less than z, but I don't want to graph this. I'm going to graph it when I read the z first. So put the word or and start with the z. You would tell me that z is greater than 1. And so that's what I wrote here. Z is greater than 1, and I boxed my answer. And now, z can never ever equal 1, so I put that open force field, that open dot around the 1 to protect it. And then it's telling me to shade to the right, shade to the right. So I shade everything to the right. And notice, as long as the z is written first, this inequality, the is greater than, will match the blue arrow.